All right, welcome to The Explainer. Today we're diving into the history of AI, and trust me, it's an incredible story, full of brilliant ideas, some pretty intense rivalries, and a revolution that is literally changing our world as we speak.
So where does this whole thing even start? Well, you have to go back to 1950, to this one really powerful question from the mathematician Alan Turing. He just asked, can machines think? And you know, this wasn't just some abstract thought experiment, it was the spark, the Big Bang, really, that kicked off the entire field of AI. He even came up with the famous Turing test to try and answer it.
And man, the path from that one question has been a total roller coaster. You've got the term artificial intelligence getting coined in '56 with all this optimism. But then, that excitement completely fizzled out into what we call the AI winter. It really wasn't until the 2010s, with a few key breakthroughs, that everything, and I mean everything, changed.
Okay, so let's talk about the first big idea in AI. It was called symbolic AI. And the dream behind it was, well, it was simple but also crazy ambitious. The thinking was, hey, what if we could just write down every single logical rule that our brains use? Map out human thought itself. If we could do that, we could just program a machine to be intelligent.
So really, the whole history of AI is a story of these two competing ideas. On one side, you've got symbolic AI, this top-down approach. Think of it like trying to install intelligence with a perfect set of instructions. But on the other side, you had this bottom-up idea called connectionism. The goal there was to grow intelligence by letting a system learn from data, kind of like how a kid's brain develops. For a long, long time, the rule makers were winning.
And for a while, it really looked like they were onto something. These early programs were mind-blowing. You had the logic theorist proving math theorems all by itself, a checkers program that taught itself to play better than its own creator. And then by the 70s, you get these expert systems, like one called Mycin, that used these massive if-then rulebooks to help doctors diagnose diseases. It seemed like the future was going to be perfectly logical.
But there was a giant catch. All these perfect rule-based systems, they worked great in clean, predictable environments, like a chessboard or a math problem. The second they came up against the messy, chaotic, unpredictable real world, they just completely fell apart.
So let's get into why they failed. It's super important. First, this thing called the combinatorial explosion. Just think about trying to describe a cat using rules. You'd need a rule for a cat in the sun, a cat in the shade, a fluffy cat, a sleeping cat. You'd need millions of rules, and it would just explode. They were also really fragile. See, one thing that wasn't in the rulebook, the whole system would crash. Plus, getting all those rules from human experts was incredibly slow and expensive. But maybe the biggest problem of all? They had zero intuition. How do you write an if-then rule for knowing your friend's face in a crowd? Or understanding sarcasm? You just can't.
And all these failures, they led to this huge wave of disappointment. The funding just vanished. All the big promises were broken. The entire field just went cold. It's what everyone now calls the AI winter. That big dream of perfect logical rules, it had completely frozen over.
But while that whole symbolic world was in hibernation, that other idea, connectionism, was still there, just waiting in the wings. The question was totally different. Instead of programming rules, what if a machine could learn the rules on its own, just by looking at tons of examples? This whole new way of thinking was inspired by the best learning machine out there, our own brain.
And the tech that makes this possible is the artificial neural network. Just think of it like a super simplified computer model of the brain. You have layers of these little digital neurons, and they're all connected. Each connection has a weight or a strength. You can think of it like a synapse in your brain. And the real magic isn't the structure, it's the fact that it can change.
So how does it actually learn? It's basically a simple but really powerful loop. Step 1. The network sees something, like a picture, and it makes a guess. That's a cat. Step 2. It compares its guess to the right answer and measures how wrong it was. Oops, that was a dog. Step 3. It uses that mistake to go back and tweak all its internal connections, just a tiny bit, so it's more likely to be right next time. And step 4. You just repeat that loop, millions, even billions of times.
It's trial and error, but on a totally superhuman scale. Now, the crazy thing is, this neural network idea had been around for ages, but it never really took off. Why? Because it was missing three key ingredients. And then, around the early 2010s, they all showed up at once. First, big data. Suddenly we had these massive data sets like ImageNet, with millions of labeled pictures for the AIs to learn from. Second, raw power. It turns out that GPUs, the graphics cards and gaming computers, were absolutely perfect for the kind of math these networks need. And third, we just got smarter algorithms, like convolutional neural networks, which are fantastic for understanding images. And when those three things came together, the result was like a lightning strike. So, there's this big annual AI competition called ImageNet. Before 2012, the best AI systems had about a 26% error rate at identifying objects. Not bad, but not great. Then, this deep learning model called AlexNet shows up. It didn't just win, it absolutely demolished the competition, dropping the error rate all the way down to 16%. In that one moment, everyone knew the AI winter was over. The revolution was here. Which brings us right up to today. We're now living in the middle of this revolution. All those breakthroughs in deep learning, they're not just in research labs anymore. They're in our pockets, on our screens, in our cars, often in ways we don't even realize. And if you want to pinpoint a moment where things felt different, look at this. 2016. The game is Go, which is way more complex than chess. Google's AI, AlphaGo, is playing against the world champion Lee Sedol. And then comes Move 37. The AI makes a move that is so bizarre, so alien, that every human expert on the planet thought it was a bug, a mistake. But it wasn't. It was a move of pure genius that ended up winning the game. It was the first time a machine did something that felt creative, something no human would have ever thought of.
And then, just 1 year later, in 2017, another earthquake hits the AI world. This time, it was the invention of something called the transformer architecture. And this is huge, because this was the breakthrough that finally let AI understand context in language on a massive scale. If you've used a modern chatbot or Google Translate, you've used a transformer. It's the engine behind pretty much all of it.
So where is all this stuff actually being used now? Well, it's pretty much everywhere. You can see the two biggest slices of the pie are computer vision, that's AI that can see, and natural language processing, or AI that can understand what we say and write. But it's also the magic behind all those recommendations you get, it's in autonomous systems, and it's even helping us make huge leaps in science.
And this is where it really hits home for you. You unlock your phone with your face? That's computer vision. Ask your voice assistant for the weather? That's natural language processing. The way Netflix or Spotify just knows what you'll like next? That's a recommendation system. That whole long journey we just talked about, it leads directly to these little bits of magic we use every single day.
But, and this is a big but, the story is not over. Not by a long shot. For all the amazing things today's AI can do, it still has some pretty big limitations. And that brings us to the next big quest. So these are the next great mountains for researchers to climb. Maybe the biggest one of all is just common sense. Right now, no AI has the basic, intuitive understanding of the world that a toddler picks up just by watching and playing. Then there's true reasoning, moving beyond just recognizing patterns to actually planning and thinking in logical steps. And a huge piece of the puzzle is called self-supervised learning, which is about letting AI learn from the raw, messy world without us having to label everything for it first, just like humans do. And so we kind of end up right back where we started, with a huge question. The first age of AI tried to hard-code reason into a machine, and it failed. This second age, our age, has basically mastered perception by learning from data. The great challenge, the next quest, is to finally bridge that gap. Can these amazing pattern-matching machines ever learn to truly reason? The answer to that question is going to write the next chapter of this whole story. Thanks for joining me.